we are going to introduce the numerical integration. Why do we need numerical integration? It sounds like it's really manual and really like you have to do a lot of things manually, and then you have to remember like certain rule, and you just put in the number into the equation. It sounds not really something that you need to do, but it's actually important in some case. For example, when you encounter an equation, a function that is so difficult to do the integration, but you still want to know the area value of it. So in that case, we could use numerical integration. So for the numerical integration, there are three methods. The first one, I think, is the easiest one. So that's what we are going to do today. And the first one is the midpoint rule. And the second one will be trapezoid rule. And the third one will be Simpson rule. And we will introduce each of the rule. But let's start with the easiest one, which is midpoint rule today. So midpoint rule. So when you see the terminology here, it literally asks you to find the midpoint. So what's midpoint? Who's midpoint? So you want to know the midpoint of the x value. So that will give you the y value. What does that mean? Let's draw the picture here. So let's say here is a function f of x, and here is your x1, x sub 1, x sub 2, x sub 3, x sub 4, and here is your x sub n. So here will be, so what's the midpoint here? From x1 to x2. So here will be x1 plus x2 divided by 2, and let's say this one is x bar, x1 bar, x sub 1 bar, okay. And then here, same concept. It will be x bar sub s sub 2 bar, and here will be x3 sub 3 bar. Okay, so when we have the x bar value, and then we will know its height over here, because these height are actually x1 bar, f of x. Yeah, f of x sub 1 bar. Okay, and here is your f of x sub 2 bar, and here is your f of x sub 3 bar, right? So forth and so on. So very straightforward. We find the midpoint of your x value first, and the second you find your y value correspondingly. So now we want to use the midpoint here, the midpoint height, because then we will know the area of this yellow square. Because you know here is your width, and here is your height. Your height will be f of x sub 1 bar. So we will just simply times them together, because we all know width times height will be the rectangle area. Okay, so the width will be, because you divided them by n, so which will be your xn minus x1 divided by n, and your height will be all of those value, which will be f of x bar, s sub 1 bar, plus f of x sub 2 bar, all the way to f of x sub, it's too big, let's shrink it a little bit, x we'll make it smaller. Okay, so here will be your x sub n. Oh, too small. X sub, oh, too big. Okay, x sub n minus 1 bar. Okay, so as you can see here, this is the equation. So let's make an example here. Let me think. For example, let's calculate the easiest one. Okay. So let's say you have a. I don't think I have to draw. Yeah. So let's say we have to calculate the integration from 0 to 2 of x to the power of 2 with respect to x. We want to calculate this. So in this case, it's actually not very difficult, but difficult to do integration, because we all know this is very, very simple to do the integration. But I just want to use this as an example. So like an easy example, so you will like find it easy to apply. Okay, I think I need a new layer. So let's say from 0 to 2, integration from 0 to 2 of x to the power of 2 with respect to x. Okay, so we want to know the value by using the midpoint rule. I will write like this. And then let's say our n is equals to 4. So let's see, from 2 to 0, your xn will be 2 minus, I think I should use yellow color. Okay, here. It will be x sub n will be your 2 minus x sub 1 will be your 0, and then divided by n, which will be 4 in this case. And then you divide it then into like n, 4. So you will have x1, x2, x3, 1, 2, 3, x sub 4, x sub 5, because then you will have n, 1n, 2n, 3n, 4n. Okay, and then your x1 will be definitely, 0. And then your x5 will be definitely 2. And then because your xn, s sub n minus x1 divided by 4 is actually 1 over 2. So which your here will be 0 plus 1 over 2. And then here will be 1 over 4. And here will be, I don't know what I was doing. Should be 1. And then here should be 3 over 2. And here will be 5 over 2. Oh, not here, sorry. I don't know what I'm doing. It must be late now, so I'm so tired. So it will be your x2, and here will be your x3, 1. And then here will be your 3 over 2. Yeah. So your x1 bar will be 0, 0 plus 1 over 2 divided by 2. I think this is too simple. I don't have to write down like this. Which will be 1 all over 4. And this one will be 3 all over 4, your x2 bar. And here will be, I think I will write it down, sorry. It's too crowded here. S sub 2 bar will be 3 all over 4, and your x3 bar, s sub 3 bar will be, 5 all over 4, and your x4 bar will be, let me see, it's very simple, just have 2 plus 2 here, so it will be 7. 4 is 7 over 4, yeah. So now you have these 4 values, then you will plug them in. There will be your f of x1 bar, which will be 1 all over 4, and your equation is here. Okay, so it will be to the power of 2 plus 3 all over 4 to the power of 2 plus 5 all over 4 to the power of 2 plus 7 over 4 to the power of 2. Okay, and add them together, which will be 21 all over 8. This is using the midpoint rule to do a numerical integration, a very simple example.